Hello everyone, let us see next example. These are some homeworks for you. Depend on the earlier, we have seen what are the definitions of analytical function, harmonic function. Okay, depend on that. We have studied some few examples. These are some homeworks for you. Determine the analytical function whose real part is number 1 log of under root x square plus y square. Real part means what is our analytical function? fz. fz is equal to u plus iv is our analytical function. This is real part and this is imaginary part. V is the imaginary part, u is the real part. Okay, real part given, in this example the real part is given means u is given, and we have to find out analytical function the fz. U is given, that means we have to find out v. Okay, the first example is log of under root u is equal to, you have to start with f of z is equal to u plus iv, where u is equal to log of under root x square plus y square. You have to calculate as per earlier example. You have to take derivatives of u with respect to x and with respect to y. Log derivative is, if it is u, okay, and convert this into this log of x square plus y square raised to half. Okay, which is equal to, according to log property, half comes to this half log x square plus y square. Okay, this is the hint for this example, and you can take now derivative of this. Instead of taking derivative of this, it is very easy to take derivative of this. Half is a constant using log property. Okay, let us calculate one derivative by u by del by x. U derivative with respect to x, half is a constant, log x derivative is 1 upon x, that is 1 upon x square plus y square, into derivative of this bracket should be multiplied by chain rule with respect to x. Derivative of this bracket is 2x. Okay, 2 gets cancelled. Answer for w by del by x is x upon x square plus y square. W by del by y, the difference is only half is as it is 1 log x derivative is 1 upon x square plus y square into this multiplication with respect to y should be multiplied by 2y only. That is only difference between derivative of x and derivative of y. 2 gets cancelled. Y upon x square plus y square will be derivative of w by del x. Okay, this is your first example. This is u. You have to find v, and final answer should be f of z is equal to u plus iv. Okay, number 2, u is given cos x cos hyperbolic y. This is a very easy example. It is u hyperbolic function, and this is normal trigonometry cos x. Okay, now these are also homeworks. Determine analytical function whose imaginary part is. Now in these two examples, imaginary part, that means v is given, and you have to find out analytical function, that means you have to find u, and then at the last you have to write f of z is equal to addition of u plus iv. Okay, both example we have just studied. Now number next, if f of z is equal to this is given, is analytical function given, this is analytical function, that means this is u, this is v. Find the values of a, b, c and d. Okay, here fz, let us solve this example. Okay, this fz is given u plus iv. Here u is, answer start from u is equal to x square plus axy plus by square, and v is equal to cx square plus dxy plus y square. Okay, this is here, this is v. fz is analytic. That means it must satisfy CR equations. What are CR equations? W by W x is equal to W by W y, and W by W y is equal to minus W by W x. Okay, let us start this derivatives first. W by W x is equal to u derivative with respect to x is 2x. In that case, y and other alphabets are constants. Here plus ay is a constant, x derivative is 1, and here it doesn't contain x, that's why derivative is 0. W by Wx. Now W by Wy, derivative of u with respect to y is here, ax, y derivative is 1, plus y square derivative is 2, b is constant, 2by. Okay, now W by Wx, v derivative with respect to x is 2cx here plus dy. It doesn't contain x, that's why y square derivative is with respect to x is 0. Now W by Wy, which derivative with respect to y? Here is y, it doesn't contain y, that's why it is constant, that's why its derivative is 0. Here y is there, y derivative is 1, dx is constant, plus y square derivative is 2y. Okay, now we have to use these two equations. This is equal to this, that means W by Wx is equal to W by Wy. We get 2x plus ay is equal to dx plus 2y, and W by Wy is equal to minus W by Wx. This is equal to minus of this, that's why, and ax plus 2by is equal to minus vx, that is minus 2cx plus minus dy. Okay, you get these two equations using CR equations. Now this is one polynomial, this is other polynomial or equation in x and y. Okay, and two polynomials are equal means their corresponding coefficients of variables must be equal. Okay, this expression equal to this expression means if these two things have to be equal, their corresponding coefficients of x and y must be equal. That's why comparing x coefficient here is 2, here x coefficient is d, that's why d equal to 2. Here a is equal to again 2. Now here a already here. Now here x coefficient is a and here x coefficient is minus 2c. Okay, now already we have a is equal to 2, therefore 2 is equal to minus 2c, therefore c is equal to minus 1. Okay, now last, here y coefficient is 2b is equal to, here y coefficient is minus d. Already we calculate b, d is 2, that's why 2b is equal to minus 2, that's for b is equal to minus 1. Okay, this is the answer for values of a, b, c and d. Okay, write down the conclusive statement a, b, c, d values. Okay, now next, prove that u is given x square minus y square minus 2xy minus 2x plus 3y is harmonic function. Harmonic function means what? It must satisfy Laplace equation. This Laplace equation? U must satisfy Laplace equation, then and then only U is called harmonic function. We have to prove that. That means you have to prove this. Dava square bu by dava x square. Already we have seen these examples. Equal to 0. Calculate u derivative, double derivative with respect to x and double derivative of u with respect to y. Add these two expression, it must be 0. You have to prove that this. Okay, first question is we have to prove this is harmonic function, and find a function v such that fz is analytical. Okay, like this, u is given. Okay, you have to find v like earlier method. Answer is this. Okay, this is homework. Already we have solved this. No. Next is, find m such that function fz expressed in the polar coordinates as fz is written like this: r square cos 2 theta plus I r square sin m theta. Okay, this is u, this is v obviously, but it is in the polar form. That means we have to use the polar form of a CR equation, and it is given that fz is already analytic. Then and then only, if fz is analytic, then and then only we can use CR equations. Is analytical. Okay, we have to find, what is the question? We have to find small m, which is present over here. Okay, let us start with the function in polar form. Fz, this is in the polar form obviously. Fz is analytic. If it is not given in the example itself, that is, it is not a polar form, if it is excluded, then also you have to understand that is fz is given in the r and theta form. It doesn't contain x and y. That's why it is a polar form. Okay, we have to use the polar form of a CR equation. Now in polar form, fz is analytical, then or analytic, then CR equations are given by, these are two CR equations in polar form. We have already studied in the third theory part. Now, where fz is equal to u plus iv, this is our standard assumption. Here u is this, it is given. U is r square cos 2 theta, and v is coefficient of I, that is r square sin m theta. Okay. Now start with the derivatives. Again, derivatives are partial derivatives, means w by delta theta means u derivative with respect to theta, and that time r is constant, and u derivative with respect to r, that time theta is constant. Now consider this first, w by delta theta. U and v both are given, that's why we have to find all the four derivatives. First, u derivative with respect to theta is r square is a constant, keep that as it is. Cos 2 theta derivative is minus 2 sin 2 theta. 2 theta derivative must be multiplied, that is 2. Cos derivative is minus sin. Okay. Now w by delta r, that time theta is constant, cos theta is as it is, r square derivative is only 2r. Now v derivative is with respect to theta. Theta is here, r square as it is. Sin m theta derivative is cos m theta into m theta derivative should be multiplied. Keep that before m. And delta v by delta r, v derivative with respect to r means theta is constant, sin m theta as it is, and r square derivative is 2r. Okay, these are four derivatives we have calculated according to this CR equations. Now comparing these CR equations, put these values in the here. What we get? W by delta theta is equal to minus r, W by delta r is equal to, put these two values here, we get this equal to minus r as it is, and this equation, this term, r into r square, and 2r square is minus 2r square is sin e2 theta is equal to minus 2r square sin m theta. And from here only we can calculate m value, but we have to write the second equation also. W by delta r is equal to 1 by r W by delta theta. Put these values here, we get 2r cos 2 theta is equal to 1 by r W by delta theta is here, this m r square cos m theta. 1 r gets cancelled, answer is m r cos m theta. Now comparing these two equations, on the both the side minus 2r square, it's constant, sin is there, theta is there. What is the value of m? 2. By comparing both the equations. Okay, here also m is 2r cos 2 theta. Okay, 2 is there, here r is there, cos is there, again theta is there, both the time on the both the places m is there. Comparing, we get m value is 2. Okay, from the both the equations. This is our question. Next example. Show that the function f of z under root of mod of x and y, x into y, is not regular at origin, although Cauchy-Riemann equations are satisfied. Okay, here what is the meaning of regular? Analytical function have three synonyms words. One is analytic, second one is regular, means analytic, and third one is holomorphic function. Three words are same. Now what is the question? Show that we have to show that this function is not analytic at origin. Okay, we have to show that this function f of z, which is given in the under root of mod of x into y, is not regular, means it is not analytical at a point origin. Origin means at point 0 0. It is not analytical. Okay, here we have to use some different method or some different formula. You have to mug up those formulas also. And other question is, although means though they satisfy CR equations. Okay, we know if function is analytical, then function satisfies CR equation. But in this particular example, we have to show this function is not analytical at origin, but they satisfy CR equation at that point origin only. Everything is at that point origin. Okay, let us start with some node. Before writing this example, write down this node first. Node at origin. At origin means at origin 0 0. Dou u by dou x derivatives can be calculated using this formula. Dou u by dou x is equal to limit as x tends to 0 uxy. Uxy means u is a function of two variables. Okay, x and y. U is a function of two variable x and y. Okay, what is the meaning of u of x0? U of x0 means value of y is equal to 0. Okay, u of 0 0 means value of x and y both 0. Suppose u of 0y means value of x is 0. Okay, in that sense. There, this is the definition. Write down before this example. Dou u by dou x is equal to limit x tends to 0. This x tends to 0. Ux, this x should be there. X and y, and x is there. Y should be 0. Minus u 0 0 divided by x. Similarly, what is dou u by dou y? Just replace x by y. Y tends to 0. U 0 y. Y should be there. X would be 0. Minus u 0 0 is same divided by y. And similarly for v also, just replace u by v everywhere to calculate derivatives of v with respect to x and y. Okay, just remember one definition only. At origin 0 0 dou u by dou x is this. Now let us start the example. Let f of z is equal to u plus iv, which is given under root of mod of xy. It doesn't contain I, that's why it is a real part u, and v is obviously, write down plus 0i. You can write plus 0i, that means v is equal to 0, or if I term is not there, v is equal to 0. Okay, now we have to calculate, we have to find out, we have to show that it is not a regular, means this is not analytical function. Okay, let us start. Dou u by dou x means limit as x tends to 0 let us prove first these CR equations, because we can easily calculate derivatives first. Okay, first calculate all the derivatives of this is u, this is v, all the derivatives of u and v. Okay, dou u by dou x, this is the formula. Limit as x tends to 0 ux0 minus u0 0 divided by x. Now u, what is ux0? Value of y in u is 0. Put value of y in u is 0. Here is u. Put value of y is 0 means u becomes 0. Minus u0 0 means put x is equal to 0, y is equal to 0 in u, means it is again 0. 0 minus 0 divided by x, and numerator is 0, that's why answer for this is 0. Okay, now consider next dou u by dou x or dou u by dou y is limit as y tends to 0. Instead of x, we should replace y tends to 0. U 0 now. X is 0, y should be there. 0y minus u 0 0. This is same divided by this y. Now what is meant by u 0y? Put x is equal to 0 in u. We get again 0. And u 0 is again 0. And numerator is 0. That's why this limit becomes 0. Similarly, dou v by dou x, just replace u by v. V is itself 0, that's why derivatives of these two are 0. Okay, now this all terms get 0, that's why from our equation del y over del x is equal to del v by del y, and del y over del y must be equal to minus either positive negative, 0 doesn't change, that's why it is minus del v by del x. That means this function satisfies CR equation. We cannot directly calculate derivatives because mod function is there. Okay, that's why we have used this definition of derivative. Okay, now first second part we have completed, that CR equations are satisfied by this function, but this is not an analytical function, we have to prove now. Now what is the definition of analytical function here? Basic theoretical question. See here, okay, see, a single valued function f of z is called analytical function if f of z possesses a unique derivative at every point of region R. Okay, what is the meaning of this? Fz is, if you calculate fz possesses unique derivative, if you calculate derivative of fz at every point in the given region, value of derivative must be same. Unique means same. At every point of this given region, fz possesses unique derivative. Now this is called analytic function. Now what we have to prove? This function is not analytical means at some point this function doesn't possesses unique derivative. That's why what is our method? First we have to find out derivative f dash z by using theoretical this definition. Okay, let us see. Okay, let us see. Let's find now f dash of 0. Of course, f dash of 0 means this is not regular, we have to find at origin. This is very important. That's why we have to calculate derivative at origin. That means f dash of 0. Okay, now this is the definition of the function at origin. That is f dash of 0. Fz is our regular function. F dash of, see what is our function? F of, if f of x is there, we call it as f dash x is derivative of fx. Okay, if we find out derivative of f of x at particular points x is equal to 2 means what? F dash of 2. This is the nomenclature of derivative. That's same way. What is our function? F of z is our function. Its derivative means f dash of z. At a particular point origin we have to find out. That's why origin means x is equal to 0, y is equal to 0. Okay, means 0 0 order pair. Z is equal to x plus iy. If you put 0 0 here, we get z is equal to 0. That means derivative of z at a particular point origin means f dash of 0 we have to find out. Okay, now here this is the derivative for definition. Write down as a note itself. F dash of 0 is equal to limit z tends to 0 f of z minus f of 0 divided by z minus 0. Okay, this is same as this, but here only one point is there, but here two order pairs are there. That's why we are differentiating this points only. F of z minus f of 0 divided by z minus 0. Write down this definition. Now put the values here. Limit z tends to 0. F of z is, and governed function is in the root x mod of xy minus f of 0 means put x is equal to 0, y is equal to 0, we get 0 here, divided by z. Put z is equal to x plus iy. Okay, minus 0 as it is. That's why f dash 0 is equal to limit at z tends to 0. This 0 gets cancelled. Root of xy upon x plus iy. Okay, now next we have to here This is important step. Now put y is equal to mx. We have to what do you mean by derivative? Derivative is nothing but dy by dx. Okay. Now we have to find out f dash of 0 in single point. We have to convert this into single variable, so that put y is equal to mx in above equation. Okay. This is slope. Okay. M is a slope as z tends to 0. Okay. Now put here z tends to 0, y is equal to mx. Put this value here, we get f dash of 0 is equal to limit as z tends to 0 means x and y both are tends to 0, under root of x as it is, y value is mx here, divided by x as it is, I as it is, y is equal to mx here. Okay. Now in numerator, x square root gets outside, we get as numerator x into root of m mod m, that is mod should be there. Okay. And from denominator x gets cancelled with the numerator. The answer is limit z tends to 0 root of mod m upon 1 plus I m. Okay. Now m is a number, it is not variable, and depend on m, value of f dash of 0 changes. This limit is not unique as it depends on value of m, right? That's why f dash 0 not exist. If it is unique, then it must be same for every point, but value of this limit depend on this number. If this number changes, f dash of 0 changes. That means f dash of 0 is not unique at every point. That means f dash of 0 not exist. Okay. Therefore, f of z, which is given root of mod of xy, is not a analytical function. What is the final statement? Fz given in the example is not regular at origin, though it satisfies, with this we already proved, it satisfies CR equation. Okay. Here is one homework for you. Show that the function f of z is equal to this. If z not equal to 0, obviously this is there, and f of z is equal to 0. Value of f of z is equal to 0. If z is equal to 0 means value of f of 0 is given 0 here. Okay. Now satisfies CR equation at origin, but f dash z does not exist at origin. Same example like this. Okay. Fz is given in this form. This is the refer example number. This is 11. Okay. Same formula. Now given here some hint for you. Given fz is equal to u plus iv. Here only root of mod of xy is there. That's why v is 0 and u is this. Here we have to separate out the real and imaginary part here. That's why separate out this numerator. We get 2x square y plus 2i xy square here, divided by denominator as it is. Now separate out this denominator. We get 2x square y upon x square plus y square, plus I is there as it is. Take outside 2xy square upon x square plus y square. This is in the form of u plus iv. U is given this, u is this, and v is this. Okay. Now given f of 0, this is f of 0 is 0 given, and we have to find out f dash of 0, and we have to show that f dash 0 doesn't exist like this, and it is not analytical at origin. Okay. Same example. This is a homework for you. Okay. Now let us see next example. Find m such that f of z is given, this is u, this is a v, directly it is given, is analytical. This is a straightforward question. If z is analytical, this is given. That means it must satisfy CR equation in obviously Cartesian form. And we have to find out m. It is very easy. Let us start. Here derivatives are only different. Let f of z is equal to u plus iv, where u is equal to half log x square plus y square, and v is equal to tan inverse mx upon y. Okay, now we have to find out derivatives of u and v with respect to x and y both. First, del by u by del by x is half as it is, log derivative is 1 upon x, that is 1 upon x square plus y square, into derivative of x square plus y square must be multiplied with respect to x, that is 2x. 2 gets cancelled, answer is x upon x square plus y square. Simply del by u by del by y, the only difference is multiply this chain rule derivative is different only, that is 2y. Okay, 2 gets cancelled, y upon x square plus y square. Now v derivative, del by v by del by x. Now what is tan inverse x derivative? Derivative of tan inverse x is 1 upon 1 plus x square is the derivative of tan inverse x. Apply that derivative here, we get, this is your x, assume that this is x, tan inverse x derivative is 1 upon 1 plus this number square. But this is not only x, that's why this derivative of this bracket must be multiplied with respect to x, where y is constant, m is also constant, that's why x derivative is only 1, m upon y as it is. Okay, now simplify, this is equal to y square, this is in the denominator, m square x square upon y square is there, cross multiply, that y square comes to numerator, y square upon y square plus m square x square into this as it is. 1 y gets cancelled, we get m into y upon y square plus m square x square is the derivative of v with respect to x. Now del by v by del by y. Now v derivative with respect to y, that time x is constant, tan inverse x derivative should be applied there, 1 upon 1 plus x square, and derivative of this term with respect to y should be multiplied. Where is y? 1 upon y derivative is minus 1 upon y square. Mx is a constant, keep that as it is. Okay, now simplify again, this y square upon this y square plus m square x square, this term as it is, y square gets cancelled, minus mx upon this denominator as it is. Okay, now all derivatives we have calculated. Now function which is the function is given analytic, and that's why if fz is analytic, then they must satisfy, then see our equations. Del by u by del by x is equal to del by u by del by y. Del by u by del by y is equal to del by minus del by v by del by x. Now put these values here, above to here. Okay, now you compare these two equations. Okay, here x is there, here x is there, obviously minus m, value of m must be minus 1. Okay, here also minus 1, value of comparing these two, it is not plus 1, it must be minus 1 to get equalize these terms. In both the equation m must be minus 1.